All right, so this should not say test. Sorry, I was doing a test earlier and now I don't feel like restarting my video. So this is going to be a quick recap of the questions that we went over in class, or that we had in class. First, solve x squared plus 2x minus 3 equals 0 by factoring. Sorry that it's a little bit blurry, but you have your own test anyway. You should start off with this. Oh my gosh. I typically always rewrite the question. If you're factoring, we should be factoring into two sets of parentheses, especially for a quadratic. So in this case, what do I put in these parentheses? Well, I know I'm going to have an x. What I have to do next is take this 3. If you guys, those of you that had me before, recall that we made a table. So we had a times c and then b. In this case, a times c would be whatever this coefficient is, which is 1, times this number here, so 1 times negative 3. And then the b in this case is this positive 2. So really, I'm going to take factors of 3, which are, or factors of negative 3, which are negative 1, and then positive 3, or they are positive 1 and negative 3. I want the sum of one of these to equal 2. This is the number that I'm looking for. So negative 1 plus 3 gives me a positive 2. Positive 1 minus 3 equals negative 2. But I said I wanted a positive 2, right? So really, these are my solutions. So that tells me that I'm going to write a negative 1 here, a positive 3 here. Really, the two solutions to this are x minus 1 equals 0 or x plus 3 equals 0, which means that x should equal 1 or x should equal negative 3. So these should be the two solutions found by factoring. If we go on to the next one, to simplify, basically what I'm doing is I'm taking this denominator and I'm trying to see if I can divide this out of all 3 of these terms. So this one, this one, this one, right? So let's take a look. If I'm trying to factor out of the first one, the 3, all the 3's cancel, right? So the 3 in the numerator can be divided out by that denominator. So if I divide, let's say I'm looking at these two terms, sorry, better way to explain it. If I'm looking at those two terms, 3 divided by 3 leaves me with just 1. A squared divided by a squared leaves me with just 1. And b cubed divided by b leaves me with a b squared. So really dividing those two terms leaves me with just the b squared. Everything else became a 1. If I'm looking at these two terms now, we can see that the negative 12 divided by 3 leaves me with a negative 4. A to the 4th divided by a squared leaves me with an a squared. B to the 3rd divided by b leaves me with a b squared. So that should be that second term. Now if I'm looking at these two terms, 6 divided by 3 gives me a positive 2. A cubed divided by a squared gives me just an a. B squared divided by b leaves me with just a b. So this should be the overall simplified version of that expression. If we go on to number 3, we can see that you find the solutions to the following by completing the square. Hopefully those of you that had me last year remember this. So we've got x squared minus a 10x. Every time I'm completing the square, my first step is to add a box or add a square, if you want to remember it that way. But if we do something to one side of my equation, I have to do it to the other side of my equation. What do I put in that box, though? Well, you always take the coefficient of the x. So in this case, the negative 10. You're always going to divide by 2, and you're always going to square it. That's just the process to do it. In this case, negative 5 is what the parentheses give me. Negative 5 squared gives me 25. So that's what goes into both of these boxes, is a 25. Notice it's positive. From here, we can continue to work. So really, this whole term becomes a perfect square now. So if I want to rewrite it as something squared, I'm going to come down over here. Something squared. We know that it's going to have an x in it. And then to get this positive 25, we can do that table again if you guys want to. So the a times c and then the b. So I've got a is 1, C is 25, and then B is negative 10. So really multiples of 25. So I've got 1 and 25, and then I've probably got 5 and 5. I can't think of any other nice ones. So both of them would have to be positive, or both of them would have to be negative, right? So negative 1 minus 25, or negative 5 and negative 5. So if I were to add these, I'm going to get 26 here. Adding these would give me a positive 10. Adding these would give me a negative 26. And adding these would give me a negative 10. I really wanted the negative 10, which gives me these solutions, right? So that means the negative 5s are what I'm going to put in here. So negative 5 is what I put in there. Or you can think of it also as whatever number you have in here is going to go straight into here. Whatever is easier. Now I'm going to look at this side of my equation. So this should all equal 11 plus 25, which is really 36. If we go down a little bit, I want the x by itself, so I'm going to take a square root of both sides. So taking a square root of both sides will cancel out this square, so I'm left with x minus 5 equals plus or minus 6. In this case, add 5 to both sides so that I can get that x by itself. So really I would end up with x is equal to 5 plus or minus 6. So if I did 5 plus 6, I would end up with x equals 11. Or if I did 5 minus 6, x would equal negative 1. So both of these are solutions. And we found those solutions by completing the square. If we go on to the next one, write an equation of a line that's perpendicular to this line. So first I need to figure out what the slope of this line is. So I would personally put it into slope-intercept form, so subtract 3x from both sides. So that would leave me with y is equal to negative 3x plus 2. In this case, I can see that this negative 3 is my slope. If I'm trying to find a line that is perpendicular to that, to do that, I get that slope and I find the opposite reciprocal of it. So in that case, this is really 3 over 1, and it's positive. The opposite reciprocal, so the perpendicular slope, should be these numbers flipped and change the sign. So since this is already positive, I'm going to change it to negative. Since it's 3 over 1, I'm going to change it to 1 over 3. So really, any equation with this slope would be correct. So y equals negative 1/3 x plus whatever number you decide to put here. That would be the correct answer. Or you could just leave it without a number. Either way is fine. For number 5, you write the inequality that's represented in the graph. So it's really similar to a line. So what I would do, the only thing is that there's no equal sign. It's an inequality, right? So I would say y. Then I need to find my slope and my intercept. So we can see that my y-intercept is down here at negative 4. So I'm going to have a negative 4 for my intercept. If I were to try to find the slope, notice I go up 2 and then over 1. So 2 over 1. Now I need to figure out which symbol do I put in. Do I put in a less than, do I put in a greater than, or do I put an equal sign? Well, since this is an inequality, you can tell that there's some stuff shaded down here. If there's ever stuff shaded, you know you're not going to use an equal sign, so not equals. It's between these two, so which one do I pick? Well, you'll always want to pick a number that is inside your shaded area. So for example, if I were to look at, let's say this point here, this is my x-axis, so the point 4, 0 that is in the shaded area, I'm going to want to plug that into my inequality here to help me figure out which symbol to put. So if this is my x, this is my y would be 0, x would be 4, so 0, h minus 4. So if I'm comparing the numbers 0 and 4, 4 is going to be greater than 0, right? So that tells me that this should be the equation. This should be my inequality. So always pick a number that's in the shaded area to test to see which value you're going to put in. The next question says that there's an area of a trapezoid. People thought that this was a geometry problem. It's not a geometry problem. You're just solving for the letter b sub 1. So in this case, if I have a b sub 1 right here, I want to get everything else away from it. So my goal is to isolate that variable. I want to get rid of this 1/2 first because I personally don't care for fractions, so let's get rid of them. So if I'm trying to get rid of that 1/2, I would probably multiply both sides by the number 2, right? So multiply a by 2 and then multiply all of this stuff by 2. In that case, I've got 2a is equal to, the 2 and the 1/2 cancel each other out, so I'm left with h times b1 plus b2. Now I want to get the h out of there because then I'll leave the parentheses alone and I can easily isolate b sub 1. So I would have to divide by h on both sides. So in this case, we've got 2a divided by h equals, those cancel. So we've got b sub 1 plus b sub 2. Final step to get b sub 1 by itself is just to subtract that b sub 2. So really, I should end up with 2a divided by h minus b sub 2 equals b sub 1. So that should be my final solution, or that is my final solution. On to the next one. Factor 6x squared minus 216. So in this case, you need to see what you can divide out of both of these terms. I can easily see that a 6 comes out of those. So if I divide out a 6, then I can see that there would be an x squared left, and then we've still got a minus, and then 216 divided by 6 would leave me with 36. Now that I'm looking at this term, I can actually see that this is a difference of squares, meaning that this is a perfect square, and so is this negative 36. So with that being said, I'm going to carry down this 6, leave it where it's at. If we have a difference of squares, then we can factor that out as well. We know we're going to have x's in there to give me that x squared. And I know what times itself will give me 36? Well, 6's, right? Now, since I don't have a middle term, I don't have like a 10x or a 5x or anything like that, that means that when if I were to add these or multiply it out, both of those terms would cancel out. So that tells me that I'm going to have a plus sign and a minus sign in here. You could very well factor this using the quadratic formula if you like to, but knowing and recognizing the difference of squares is what's going to make Algebra 2 easier for you. So if you have a perfect square here and a perfect square here, you're always going to have this plus and this minus, and then whatever two numbers make up this perfect square. So this should be your overall answer for number 7. Number 8, what is the y-intercept of the line that passes through these points? So what I did first is I found the slope of the line that passes through those 2 points, which is y2 minus y1 over x2 minus x1. In this case, I just substituted those values. You can take the time to label them, x1, y1, x2, y2. So negative 5 in parentheses, because it's always a good habit to do. Then we've got 2 minus a negative 4. So here I've got negative 9 divided by 6, which really simplifies to negative 3/2. With that being said, I can take that and start to do my slope-intercept form. And I'm going to substitute one of these values. So let's say I pick this one for my x and my y. So really, y is equal to 4. Slope, I said, was this negative 3/2, so that's going to come in here. X is negative 4 plus b. So we've got 4 is equal to negative 3 times negative 4 gives me a positive 12. And then we still have to divide it by this 2. So really, it equals 6 plus b. Subtracting 6 from both sides will leave me with a negative 2 is equal to b. That's a weird b, but you get the idea. So that should be your final solution. If you go on to number 9, simplify the expression. So to simplify, we're going to go ahead and distribute. So the square root of 2 times the square root of 6 would be the square root of 2 times 6. Here, if we distribute the square root of 2 times a negative 4, we can't combine those because they don't both have radicals. So here, we've got the square root of 12 minus 4 square root of 2. I can still simplify this radical by finding its factors. So 4 times 3 give me 12. If I'm going to take a square root of this, I can take a square root of this 4, right? So that becomes 2. But I still have the square root of 3 left. Here I cannot do anything to this, so that stays exactly the same. That should be my final answer for that one. Graph the equation of this line. Again, I usually just go into slope-intercept form. I'm sure you could do it another way, but that's what I prefer. So in that case, I'm going to start with this. Minus 1/2 y. I want the y to be by itself. So what I'm going to do is subtract 1 from both sides. So you've got 2x minus 1 equals negative 1/2 y. But I want that y to be by itself. It's still not alone. So I'm going to multiply both sides by a negative 2. Why would I do that? Well, that's going to get rid of this. Negative 1/2 times negative 2 leaves me with a positive y. In this case, I need to distribute. So negative 2 times 2x would give me a negative 4x. Negative 2 times negative 1 would give me a positive 2. So this is this line, really, just in a simpler form. In that case, I know my y-intercept is up here at a positive 2. I know that my slope is going to go down 4 and then to the right 1. So my line, should look something like this. You guys are smart. You get the idea. Ignore these ugly lines. So that should be more or less what your line looks like. Going on to 11, solve using the quadratic formula. Hopefully you all commit this to memory. X equals negative b plus or minus square root b squared minus 4ac all over 2a. In this case, this is your a, this is your b, this is your c. So we can go ahead and start to solve. X equals negative 10, because this coefficient is negative, plus or minus square root of the negative 10 squared minus 4 times 6 times 3 all over 2 times 6. So negative and negative, those cancel out. So really we've got x equals 10 plus or minus square root of 10. Negative 10 squared is 100. Negative 4 times 6 times 3 is going to give me a negative 72, all divided by 12. 100 minus 72 is going to leave me with 28. So I've got x equals 10 plus or minus square root of 28, all divided by 12. Now keep in mind, I can still simplify this radical. So I'm going to take this off to the side. Remember, we said to simplify, we're going to make our factors. So 28, you can factor it into 2 and 14, right? You can also do 4 and 12, right? You can do, sorry, I lied. I don't know what I'm talking about. Not 4 and 12. That's 48. You could do 4 and 7. So if that's the case, I want to pick the one with the biggest square. These are not perfect squares, but these are. So if I rewrote it as 4 times 7, I know I could take the square root of this 4. So if I did that, I'm left with 2 root 7. So back to this. I would say x equals 10 plus or minus, now I'm going to use this, 2 root 7, all divided by 12. Notice that in all of these terms, this 10, this term, and this term, I can divide them by 2, right? So really my simplified solution should be x equals 5 plus or minus. 2 divided by 2 is just 1. So I've got 1 root 7. 12 divided by 2 is 6. So this should be my overall final answer for that one, simplified as much as possible. For number 12, so we can see that we have to simplify the expression below. So really we know that if something is cubed, it's multiplied by itself 3 times. So I should have negative 6y squared times negative 6y squared times negative 6y squared. In that case, negative 6 times negative 6 gives me a positive 36. Y squared times y squared gives me y to the 4th. So these two terms combined give me this one, but I'm still left with a negative 6y squared. Now if I want to finally combine these two terms, 36 times negative 6 gives me a negative 216. Y to the 4th times y squared. We add these exponents, so give me y to the 6th. That would be my final answer for that one. Number 13, what is the solution to this? So notice, since we have an equal sign in here, I can go ahead and cross multiply to get my solution. So these two terms multiplied by each other, 2 times 2n plus 8 equals these two terms multiplied by each other. So 3 times n plus 7. In this case, distribute. So 2 times 2n is 4n. 2 times 8 is 16. 3 times n is 3n. 3 times 7 is 21. Now it's as simple as solving for n. So I'm going to subtract 3n from both sides. So n plus 16 equals 21. Subtract 16. So n should just equal 5. Yay for that one. Solve the system of equations. So this one is actually really easy if you use the elimination method. All you have to do in this case, see both of these equations. Notice how there's one y up here, and they're opposite signs. All I have to do is add these two equations to each other, and the y's are going to cancel each other out. So 3x plus 4x leaves me with a 7x. Y minus y cancels. And then negative 7 minus 14 is going to leave me with a negative 21. Gosh, that 21. So divide by 7 on both sides. X should equal 3. But we're not quite done yet because the system has a value for x and y. So, negative 3. So x is equal to negative 3. All I have to do now is substitute this negative 3 into one of these. So let's say I pick the top one. Plus y equals negative 7. So that means negative 9 plus y equals negative 7. If I add 9 to both sides. That will cancel, so we're left with y equals 2. So really the solution to this, and the solution that I would like to see going forward, would be a coordinate of negative 3 and a positive 2. So this is what I would like to see on your answers going forward if there's a system of equations. For number 15, write an expression that is equivalent to this. What I wanted you guys to do is factor and simplify. Some people multiplied everything by 2, which technically is equivalent, but I want us to get used to simplifying. So in something like this, 2x minus 12 divided by x squared minus 2x minus 24. So on here, I can see that an equivalent expression would be if I were to factor out a 2 from each of these, I could rewrite this numerator as 2 times x minus 6, right? So these are the same expression up at the top. At the bottom, we can write this as 2 factors of each other. So again, you can use the quadratic formula. You can use the little factor tree that I told you guys. We know that there's going to be an x in each of these. Let's say I go back to the factor tree. A times c, in this case 1 times negative 24. And then b is going to be a negative 2. So factors of 24, it could be 1 and 24. It could be 2 and 12. It could be 3 and, I don't know, because it's the end of the day. So, sorry, 3 and 8. It could be 4 and 6. So all of these different combinations, right? Ultimately, I want a negative 2 here. So I want a difference of 2 between these. This won't give me 2, this won't give me 2, that won't give me 2, but these could. I want it to be a negative 2. So that means if I have a negative 6 and a positive 4, and I were to add these, I would get that negative 2 that I want. Also, I can check to make sure that negative 6 times positive 4 gives me this negative 24. So that's what you want to check for. I'm going to use these here. So positive 4, negative 6. Oh, so once we do this, we can see the numerator and the denominator. They have something in common, right? They have this x minus 6. So a simplified version of this expression that would also be equivalent would be 2 divided by x plus 4. That was the answer I was looking for on that one. For number 16, what is or are the solutions for the graphed function below? So a solution is also sometimes referred to as a zero. So in that case, I'm going to look for the places where the graph intercepts the x-axis. And so in that case, I can see right here, it's at a negative 1. So at x equals negative 1. And again, over here, keep in mind that it's not counting by 2, sorry, it's counting by 1. So x equals positive 2. So these are the solutions to this function. They're also considered zeros. If a function is graphed below, tell me which one has a greater vertex. So a vertex is the very tip of this parabola. So function A has a vertex of 8, 9, 10, right? If I'm looking at this function here, I would take, and sorry, there's supposed to be an x in here. So to find the vertex, it's equal to negative b over 2a, which in this case, negative this 16 over 2 times a, which is negative 1. So negative 16 divided by negative 2, which is really 8. So the vertex of function b is 8. So 8 compared to 10, that means that function a has a greater vertex. So function a is greater. 18, given the parent function x squared, describe the transformation that occurs when you do all of this good stuff. So we know that the plus 5 actually moves the function up 5 units. So, and if you don't know that, we'll go over it a little bit more. So moves up 5 units. And you know it's because it's in the positive direction. If this was negative, it would move down 5 units. The next one is a little bit tricky though, because when you look at this plus 3, it actually means that it's moving to the left. It's actually moving in a negative direction. So moves left 3 units. So that one's a little bit tricky. Again, if you're not quite familiar with this, we're going to go over it again this semester, so don't freak out. When 3 is subtracted from a square root of 1/4 of a number, the end result is 5. What's the original number? So we know 3 is going to be subtracted from something. So I'm going to leave this little box here. If it's subtracted from the square root of 1/4 of a number, that means that I'm going to have a square root in there. So the square root of 1/4 of some number x. So this is my original setup. It equals 5. So that would be my setup, and then from there I can solve. So I would add 3 to both sides. So 8 is equal to the square root of x over 4. To get rid of that square root, I'm going to want to square both sides. So really, x divided by 4 is equal to 64. Then to get rid of this fraction, I'm going to want to multiply everything by 4. So x should really equal 256. gigantic number. You can plug that into the original equation and see if that's what you get. Should be correct. The next one, I saw a lot of mistakes just because this is actually an equal sign. It is not it's a minus sign, it's not an equal sign. So that means since it's not an equal sign, you do not cross multiply. So if you're simplifying, remember, if you're trying to subtract one fraction from another fraction, you need common denominators. So that means with this 3 over x plus 1, I need an x plus 2 to be in this denominator with it. So I'm going to multiply this by x plus 2 over x plus 2. Doesn't change the value of anything because this is just 1. Similarly, I'm going to look at this side, and I need this denominator to have whatever this one has. So I'm going to multiply x plus 1 over x plus 1. Again, not changing any values. We're just changing the way that it looks. So this times this, I'm going to distribute. So 3x plus 6. So I just distributed those. The bottom, I'm just going to leave the same. So I'm going to say x plus 2 times x plus 1 for now. So over here, I've got a minus, and then I do the same thing here. So I'm going to distribute the x squared plus x, and then at the bottom, x plus 2 times x plus 1. So they have common denominators now, so I can go ahead and combine the terms. So I can say, if I'm combining these two things, I've got x squared, the positive x, I've got 3x minus this x. So really, I've got 2 x's left up there. This should have been a negative. And then 6 minus, well, nothing over there, so plus 6. So if you combine like terms here, this is what you get. With a denominator, we're going to leave it the same. Or you can multiply it out. So you could say x squared plus 2x plus 1x plus 2. If you did that, then you'd have to just take it one step further to simplify. So you get negative x squared plus 2x plus 6 in the numerator. In the denominator, you get x squared plus 3x plus 2. That should be the final answer, the most simplified version of it. So hopefully this was helpful. If you still have questions, feel free to ask me during tutoring. Otherwise, we're going to go over a lot of this stuff as we go on through the year. So do not worry. Everything will be okay. Hopefully it makes more sense. So I will see you guys tomorrow. Thanks for watching.